Okay, so we are in part two of our expansion upon Taylor and Maclaurin series, and now I'm going to take you through a bit of pain, right? I'm going to show you some challenging things that we could wind up doing with this. And you will appreciate at the end. If you want to kind of fast forward, like watch this at 2 times the speed, you might want to, because this is going to be painful for me, and you'll be thankful at the end when you see what happens, how to do it the easy way. So we're going to do this the hard way. Okay, we have this function, and I didn't go easy. And we're doing a Maclaurin series. So whenever you're asked to do a Maclaurin series, that's literally someone asking you to do the Taylor series centered at 0. So someone is saying, okay, please find this expansion, right? They're saying, write it this way. And because it's centered at 0, you're literally just going to be doing this, okay? And this is x to the power of n. So we got to start thinking about the derivatives, right? We got to start thinking about these derivatives. And I told you this was going to be painful, and it will be. Because we have to do a product rule, right? First times the derivative of the second plus the second times the derivative of the first. Okay. Now what? Well, first times the derivative of the second. Now we have to do this one here. I think that's what? X e to the negative x minus 2e to the negative x. This doesn't look like it's going to get any easier. Well, you know what? The good news is I did this one already, right? I did this one. That was the first derivative I did. So I could just kind of copy this down here. Times the derivative of this part, which I think is going to be I'm breaking a sweat already. I'm not even close. I mean, I'm starting to see a pattern, kind of, right? I think it's like there's like 1 e to the negative x here. There's a negative 2 here. There's a plus 3. So, hopefully we'll do one more. I think that's just going to be now x e to the negative x minus e to the negative x minus e. I think that pattern is going to hold true. Okay, good. Now the good news is that we're going to evaluate this at 0, right? So we're going to be plugging in 0. So we're going to find f of 0, f prime of 0. And I'm doing this at, look, I'm doing this at a much more rapid pace than I would expect you to. That's kind of stuff where this is really quite painful for you to do, doing all those product rules. They take time. So this one looks like it's 0, right? If you plug in 0, you just get 0. And the next one, if you plug in 0, you just get what? 0 plus e to the 0. Looks like it's going to be 1. Then you get 0 minus 2 times 1. Then you get plus 0 plus 3 times 1. Minus 4. Okay. That's not too bad. So now we're going to come over here and represent this. And, this is not a bad thing to do. I've said this before. You kind of know that in Maclaurin series it's going to look like this. And the only thing that's really going to be changing in the Maclaurin series is going to be what that derivative is. This is kind of the formula, right? And we'll do one more, even though it might not be necessary. Okay, so now we can come in and plug these numbers in. So we have a 0, and we have the 1 and the negative 2, the 3, the negative 4. Okay, 1, negative 2, 3, and then negative 4. And now, how can I write this? Well, I guess I can write this as x minus 2. I'm gonna leave it this way just because we'll have to see how we can simplify that in a second. I think, you can correct me if I'm wrong, folks, but But I think 2 over 2 factorial is just like 1 over 1 factorial, right? The 3 over 3 factorial is just like 2 factorial. So I think we can rewrite this as x squared over 1 factorial. I'm just writing it so it's clear. You obviously don't need 1 factorial. Can we guess what the next term would be? Yeah, I don't think we're going out on a limb when we do that. If we had to figure out that general term, could we do it? Well, remember, this is 0, right? This is 0, and this is 1, and this is 2. So this is n equals 0, this is n equals 1, this is n equals 2. So I think we're going to have n factorial in the denominator, right? 0, 1, 2, 3, 4. But this is now x to the n plus 1, and we have a negative 1 to the n. Well, that was a good workout. And if you don't think it was a workout, try it yourself. And then the fact of the matter is, this would be really challenging with some other functions too. I mean, ultra challenging. And there's a reason why I'm showing this to you, because this was painful, right? But there's a massive shortcut. And the massive shortcut is just to do this. Remember these ones I told you it's nice to have? Remember I told you it's nice to have these in your head? See this guy right here? Have this one in your head. And you can do it with the terms, or you can do it with the general solution. But if you know this, right, if you have this one kind of in your repertoire of, yeah, I know what this is. Like, this is something I just know. You just have this one down. And you know that the general solution is just x to the n over n factorial, right? You know that. If you now then said, well, I want to kind of build to this. So what would I have to do? Well, the first thing I should do is change this is e to the x. I want to go e to the negative x. So now I'm just going to replace every instance of x with negative x. I'm allowed to do this, right? This is basic functions 101, right? If you have f of x is this function, and you want to take f of negative x, you just plug in the negative x. And you get something that instead now looks like this, right? So if you think of the general, it's going to be, e to the negative x is not going to be 1. It's just going to be alternating signs. And we did this for homework, right? This was your homework last night. And I told you last night, if you looked at my solution video, one of the things I said to you is, you'll see why there's a shortcut soon. And sure enough, we are at that soon place. So you may think, well, great. You now have x e to the negative x up here, right? And I have e to the negative x here. Well, just go ahead and multiply it, folks. Just multiply this whole thing, right? This whole thing here just gets multiplied by x. And I'm not going to take the time to go through that whole thing, because you don't want to see it, me work it out. But really all that does is change all those x's to one more, right? So it just becomes x minus x squared plus x cubed over 2 factorial minus x to the 4th over 3 factorial plus x to the 5th over 4 factorial, right? And if you think about it, that's what we get here. And this is a much shorter version. Look, did I have to take all the derivatives? Look at the green method. I didn't have to do any of that stuff in the upper right corner, right? All I had to do is say, well, if I know e to the x, e to the negative x is just plugging in negative x instead. And then if I have to multiply by x afterwards, then I can just kind of up the power for all of those terms, right? You're just kind of changing the degree by increasing it by 1. So that will help you when you're doing your next assignment, because when you are faced with a problem like this, which you will be faced with very soon, this is a very quick problem if you do it the green way. It is extremely challenging if you do it the orange way. So I'm going to recommend you do it the green way. So let's see how it works out, folks. Good luck.